Hey y'all, how's it going? Hope everything's well. So last time in class we talked a little bit about refraction. We talked about how that works and how as light goes from one medium to another it can actually slow down, but it slows down on each side different than another if it's entering at an angle, and so this can cause it to actually bend, right? That's what refraction is. So today we're actually going to be talking about lenses, right, which are kind of these specifically designed or shaped pieces of material that cause light to bend in a very particular way, right? So if we kind of go through and we can go ahead and start to fill this out. So what is a lens? This is a specifically designed or shaped piece or material that refracts light in a particular way. Boom. Right, so that's what a lens is. Lenses that you guys may be familiar with, right, include like a magnifying lens, right, which I'll mess around with here. Make my mouth all big. So magnifying lens is a classic one. Lenses are found in binoculars or like telescopes, things like that, found in cameras, so like this little webcam here that I'm using to record you guys, or in your phone. Sometimes I found this little kind of paperweight at my mom's, which is like it's a spherical kind of shape material that kind of magnifies as flowers, kind of cool. Eyeglasses, either like readers or other types of glasses. Or you can even just get these nicely little shaped, these are some actual specific lenses that I have. So you'll see lenses kind of all over the place. All right, now what type of lenses do we have? There's a couple main types that you'll end up seeing. This one here, this is what we'd call a convex lens, right? Now you'll notice that this is the same shape, right, as a convex mirror, right? It's kind of bulged outwards, right? So it's got this convex shape, it's bulging outwards, right? But this is also known as a converging lens, right? And we'll talk about why that is in a second, right? These are used in magnifying glasses, cameras, etc. And that's because these can be used to make either real or virtual images. This other type of lens that we have down here, this is what's known as a concave lens, right? And you'll notice that's because it has this kind of cave shape. It's caved in, right? Very similar to our concave mirror, right? So this is known as a concave lens, also known as a diverging lens, right? And think about what those words mean for a second. It gives you a good idea of what's actually what they do, right? What they do with the light rays that kind of pass through them. This concave lens, this isn't quite used as awesome, but a lot of times you'll see this used in glasses, like prescription glasses, as well as some other things. You don't see it quite as often as a convex lens, but it definitely does still have its uses. So if we go over what these things actually do, and you can kind of mess around with them, I've got a video here that I'm going to have you guys watch that kind of talks about the images that we can create with these. Just a few quick observations, right? You'll notice, right, this is kind of like a magnifying glass, right? This is a convex lens, right? It's kind of bent out on each side. It can be used as a magnifying glass. But this can also be used if we look at something else. Let's see if I can find something in this camera view. If we look at things at just the right distance, oh my gosh, this seems. All right, if we look at things at just the right distance, you'll see. I don't know if you guys can see that there. That is flipped upside down, right? So what's actually happening there? It can magnify close up, but then farther away it kind of flips things upside down. That's a convex lens. And then we have our concave lens, right? And this, at all distances, right, makes things just appear smaller, right? So what's going on there? How do those actually end up working? Let's talk about it in terms of ray diagrams. And how those actually work. So if you guys remember, we talked about refraction the other day, depending on the two materials that it's going through. If it's going from a material where the light is moving faster, like air, to a material where it's moving slower, right? We can think of this as like a series of waves, and if this side of the wave hits first, that means it slows down first, which means that the entire thing will shift its direction, right, towards this normal line, or it'll shift, if you're looking the other way, it'll shift to the right, right? So it kind of moves in that way. Now we could flip this, right? And we could go from a slower to a faster. And a couple things happen when we go from a slow to a fast, right? One is that there's this angle, right, at which it won't actually pass through, right? That's that critical angle where we have this internal reflection, right? So there's no transmission. But if it does pass through and it's going from slower to faster, well, if we think of this as a wave, right, this side is speeding up first, and that causes the entire thing to turn in this direction, right? If you're looking kind of from the light's perspective, you kind of turn to the left. Okay, so this is what refraction is all about. This is how it works. So depending on the angle that we're coming in at, which side of the light wave is speeding up first or slowing down first, the wave will actually bend, right? The light ray will actually bend in a particular direction. Now, what we can do is we can actually use prisms or lenses to actually show and demonstrate what's happening here. So here I have my little laser pointer, and here I've got some different lenses and prisms. You can use like prisms and those kind of things. Here I'm going to actually look at, these are essentially my lenses, right? This would be a convex lens that's bulging out, right? And you can see how that kind of bends this light wave, right? Now what's useful is if I actually put a bunch of these together, I get a stream of them, right? Then you'll see they hit this surface, right? They bend inwards, right? Because the outside is slowing down first. And then that causes them to kind of converge, which is also why it's known as a converging lens, causes them to converge and then separate. So what was the bottom is now the top. Okay, keep that in mind. Similarly here we have a concave lens or a diverging. You'll see what happens when they hit there, right? The outside kind of slows down first, so that causes them to bend away, and they actually diverge, they split, right? So these are these two main different types of lenses that we have and that you guys will see, and the effect that they kind of have. If we actually want to talk about the ray diagram as far as what's actually going on, right? Here's what we have. If we have this convex, so we've got a few different varieties. Convex far away, right, where if you guys remember it kind of flips that image. Convex close up, where it acts like a magnifying glass. And concave diverging at all distances, right, where they make the images smaller but still right side up. So let's look at what's actually happening here in terms of a ray diagram. Okay, so in terms of a ray diagram here, let's say that I'm looking at this tree from farther away and I have my lens here, right? Well, I've drawn a couple of rays going from the top, and this would be true for all rays coming off the top as far as what they do, and then similar with the bottom, but I'm only drawing a couple so that we can kind of see. And remember, wherever those rays converge, right, wherever they come together is where our eye or a sensor or a camera sees that image, right, sees that image to be. So let's look at what happens with the top here. If we follow this ray going kind of straight along, it hits this side of the mirror, or this side of the lens. And it's, let's say, so this lens, let's say, is made out of glass, right? And so light moves faster through air than it does through glass, so it's going from fast to slow, right? Well, which side of this is going to hit the glass first? Well, it's going to be this side here, right? If you're looking as, perspective from the wave, right? The right side of the wave hits the glass first. So the right side slows down, right? And the left side is still going fast, which causes it to bend like so. So this would actually bend in here like this, right? It would slightly refract in this direction, okay? So that goes there, and then it goes to this side, and the same thing actually happens. This side, right, the left side hits the air first, so it starts to speed up, so it still continues to bend to the right. So we get something, it'll continue to bend to the right, so it goes like that, let's say, right? We can analyze the same thing here, right? And this side, in this case, the left side is going to hit first, so it's going to kind of slow it down, right? And then it's going to, now the right side is going to hit air first, so it's going to speed up first, which is going to cause it to bend in this direction, something like that, right? So this, right, you'll notice here on this side of the lens, that is where the light rays are actually hitting, right, actually converging. So that is where we would see the top of this tree. Now if we look at the bottom of the tree, and we can analyze it in the same way, from the bottom here, you'll notice the right side is slowing down, or sorry, the left side is hitting the lens first, and it's going to slow down first, which is going to bend it just ever so slightly in that direction. And then same thing here, the right side is speeding up first, which is also going to bend it to the left. So we're going to get something like that. Similarly on this side, the right side is hitting the wave first, which is going to slow it down kind of to the right. It's going to bend it this way. And then here, it's going to bend then, it's going to come out mostly straight, but it's going to bend maybe just a little bit to the, we'll just say it's going out straight. All right, so this is what we end up getting. And if we actually draw in what we see here, this ends up being the bottom. And this ends up being the top. So we have the bottom of the tree is now on the top of our view, and then the top is on the bottom. So this entire image has been flipped, and what do we notice? It is also smaller. So if we wanted to write out what we end up seeing here, right, in the case of this lens, right, the image is flipped, and the image is smaller, right? So we see it as smaller, and we see it as upside down. Okay? And that's how this actually ends up working when we use this convex or converging lens from far away. Right? So those are the big takeaways. Now, if we look at the convex or the converging close up and we draw the ray diagram as best as we possibly can. Once again, here I have a letter A and it's up close. So we see I've got a line coming from here and a line coming from here. Well, what happens right here in this case? We look at this right side hits first, slows down first, which bends it in this direction. Here the outside, right, speeds up first, which also bends it in this direction. Right, so this guy goes like that. Similarly here, the left side hits first in this case, which is going to kind of slow it down in this direction. Maybe not quite that much, but that's okay. And then on this side, right, this left side speeding up first, which is going to cause it to refract in that direction. Now you'll notice that these two, and this is why this is so important, when they're up close, these two lines are never going to converge, right? They're never going to meet. So our eye can't actually pick up and does not see the image as forming on this side of the lens, right? It actually sees the image as forming somewhere back here. It follows these rays back, and wherever they converge, right, is where it sees that image as being. So it sees the top of the A as being right here. Right, is actually where it sees the top of the A as being, even though it's not actually. So this is a virtual image. We perceive it, we see it where it isn't actually. Now that compared to here, right, when the image is far away, where those rays actually converge on this side of the lens, the same side that our eye is on, right? In that case, we're actually seeing that image, right, where those light rays actually converge. Here, our brain has to kind of make it up, and it says, oh, I think that top of the A is behind, right, the lens. Right, and so that's why when you have a magnifying glass, you're looking at something, right, my eye is not actually that large. It is not there. The light rays are not coming from there, right? That is just because of the refraction, your brain has to think. It has to make it seem like that's where those rays are actually coming from. So if we look at this on the bottom, we can do the same thing. Right, here it's going to bend in a little bit. It's just silly. It's going to bend in a little bit. Beep. We'll just have to exaggerate a little bit. It's going to bend out like that, and then this guy is going to bend in just a little bit because that right side is just going to hit just a little bit first, right? And then it's going to split and it's going to diverge, and we get the same kind of thing where they're never going to come together, right? So our brain has to kind of follow those back, so we can kind of trace those out and see back here where they'll converge. And you guys should kind of notice, right, the bottom of the A, our eye sees as being down here, the top we see as being down there. So our eye thinks that we see an A that is like this size. Right? So we see an A that is bigger than it actually is, and that's how this convex lens works when we're close up. The last lens, so I guess we could fill in here. What do we actually see? Right? So we see the image is bigger than it actually is, and image is right side up. And that's what we end up with. And the last one that we have here is our concave or our diverging lens, and this is true at all distances. As we kind of mentioned, it doesn't really matter how close it is or how far away it is. It's always going to make them smaller, and it's going to make them right side up. So let's see how that actually works with our ray diagrams here. Let's start with the top of this tree. So here, if we look at this left side is slowing down first, which is causing it to bend this way. And then on this side, then the right side of it is speeding up first, which is causing it to bend even further this way. Here it's the same kind of deal, just to a lesser extent, right? And once again, if we actually do this, we would notice that these light rays aren't going to converge, right? They aren't going to come together, right, on this side of the lens. So our eye kind of traces those back to where it thinks that those light rays are coming from. And if we follow those back, we see the top of the tree as being right about there. Right, maybe not the best lens drawing, but you see the top as being there. We'll see how this bottom shakes out. Hopefully I did this okay. Same thing here. It's going to bend outwards just ever so slightly. And then same thing here. This outside is going to speed up first, so it's going to bend outwards. We get those light rays diverging. And the same happens here to a lesser extent. And we can follow these light rays back to where it is, and this is where I've done a terrible, terrible job of drawing this, because in this case, as you can see, it looks like the image is going to be flipped, but it's not actually going to be flipped, so let's go ahead and try and do a better job. You guys can fast forward through this if you guys would like to. Maybe make them a little bit less slight so that they come back to the proper spot. All right, so then we'd follow this back to here, follow this back to about here. See, the bottom is right there. And the top, we'd follow this back to there, follow this back to here. And there we go. We'd see the bottom as being about, we'd see the top as being right about here, right? So this is our top. We'd see the bottom as being right about here. So this is our bottom, right? So we notice the bottom is still on bottom, the top is still on top, but we see it significantly smaller. Okay, so we see it smaller, and it's right side up. So in this case, what we end up seeing is we see image is smaller, and image is right side up. It is also virtual. Right, it's a virtual image, it's not real. Those light rays aren't actually converging where they are in real life. Our eyes kind of have to make it up that those lines are actually converging. We could add this in here. This image also ends up being image is virtual, right? Because our eyes have to make up that the light rays are actually coming from this point that is bigger behind the lens. And the only one where they're actually real is when we have this one. And you guys may or may not have noticed or picked this up by now. But anytime that the image is flipped like this, you almost always have a real image. Right, so if your image ends up being upside down, then usually it's a sign that's a real image. So in this case, the image is real. Right, the light rays are actually converging here at this point. And this becomes a very important thing when we talk about how our eyes actually work to pick up and see things. Right, our eyes can only pick up, our cones, the cone cells in our eyes can only pick up real images. They can only sense where those light rays are converging on a single point. That's what allows us to actually see that light rays are coming from that point and that they actually exist at that point in space. So that's that. Hope that these ray diagrams kind of make sense and allow you guys to see how these lenses give us the things that we see. I'd like you guys to check out, I made a little video kind of doing some demonstrations with this, as well as kind of trying to convince you that these that convex lenses for far away objects can create real images indeed. And then we're going to talk a little bit about the human eye and how that works. So we'll see you guys in a second.